Okay, so the new thing that we need to discuss in our class is now enthalpy change during dissolution, right? When you are going to dissolve something, so what will be the enthalpy change? This is actually what we need to discuss in today's class, right, Bacho? So over here, uh, this is the previous thing that you know this, right? For example, if you have MgCl, that means the charges are +1 and -1, and if you have MgCl2, then the charges are +2 and -1, and if it is MgCl3, then the charges are +3 and -1, right? We know that when the multiple of charges are going to be increased, then definitely the exothermicity or the energy released during this process or the crystal formation will be increased. But just think about this third one. Talk about the third one. So just look at over here. This is Mg3 plus and Cl -1. That's fine for chlorine. It always receive 1 electron. But if you talk about magnesium, so we have 2,8,2 electrons for magnesium, right? So if it loses 1 electron, that's fine. If it loses the second electrons, that's fine. But if the third electron will be removed from the magnesium, it requires a lot of energy, so which going to be increase the activation energy of the whole procedure, and that is why the overall process will be endothermic. You need to remember this. This is not a feasible compound just because of this कि इसकी activation energy बहुत ज़्यादा high हो जाएगी if you want to be form magnesium of +3 charge. So इसकी activation energy इतनी ज़्यादा high हो जाएगी then it will become what? It will become endothermic reaction, right? But बच्चों?
Yes, sir.
Okay, then Born-Haber cycle की अगर हम बात करें तो we know that Born-Haber cycle के अंदर we have a lot of things, and the largest single contribution is what? It is from lattice enthalpy, right? And उसके अलावा आपके पास अगर कुछ है तो फिर ionization energy है, और उसके अलावा और भी बहुत सारे हमारे पास different signs हैं, और we know that a lot of things we learn in Born-Haber cycle. We are not going to discuss this again. It is just for your the remembrance, और ये conclusion के तौर पे यहाँ लिख दिया है मैंने ताकि आप लोगों के पास जब भी हो तो आप इसको as a conclusion देख लें, right? The thing is, for example, what happen when you dissolve these compounds or these solid crystals into the water? When you dissolve them into the water, definitely they are going to be dissolved very, very easily. You know that the lattice enthalpy of NaCl is too much or too high, right? When you heat it, so it requires almost 800 degrees centigrade to melt, right? It requires a lot of energy to break the bond or break the energy or to overcome the energy in between the ions present over there. We know that a single positive is attracted by 6 negative and a single negative is attracted by 6 positive. So it is just like a giant ionic structure of any ionic compound. So if you want to break them out or if you want to melt them, so you require a lot of energy from your side as well. You need to give a lot of energy to melt such ionic liquids, right? It is just of NaCl we are talking about. And if we talk about MgO, so MgO is +2 and -2, and it will be having more energy to melt, right? It is just like this. So अगर आप imagine करो बच्चों कि अब NaCl को मेल्ट करने के लिए ना उसके आइंस को डिसोसिएट करने के लिए आपको 800 डिग्री सेंटीग्रेड चाहिए. And if you see the melting point, or sorry, if you see the boiling point in your water of your houses, you will feel like यार 100 डिग्री सेंटीग्रेड इतना ज्यादा गर्म होता है कि हम उसके सामने खड़े नहीं हो पा रहे होते. Just realize that how much or how will be the feelings in front of 800 degree centigrade. तो तब जाके NaCl जो हम डेली बेसिस पे यूज करें वो मेल्ट होगा. बिल्कुल ऐसा लगता है बिल्कुल बेकार सी चीज है ना, हम हाथ में पकड़ के यूं करके दबा देते हैं उसको, ऐसी पीस देते हैं, ऐसी पाउडर फॉर्म में बना देते हैं. दिखने में वो कितना सॉफ्ट है, बट उसको मेल्ट होने के लिए 800 डिग्री सेंटीग्रेड चाहिए. लेकिन जब हम उसको पानी में डिसॉल्व करते हैं तो वो यूं करके डिसॉल्व हो जाता है विदाउट एनी 800 डिग्री सेंटीग्रेड टेम्परेचर. पानी में यूं ही डिसॉल्व हो गया. और अगर आप उसको वैसे उसको मेल्ट करना चाहो, उसके आइंस को डिसोसिएट करना चाहो, so you require a lot of energy. 800 डिग्री सेंटीग्रेड आपको चाहिए ही चाहिए. पानी में डाला तो विदाउट एनी टेम्परेचर इट इज गोइंग टू बी डिसोसिएटिंग इनटू इट्स आइन, और वहां वो आइंस प्रोड्यूस करना शुरू हो गया. इफ यू रिमेंबर इन योर ओ लेवल्स, तो आपने इलेक्ट्रोलिसिस में पढ़ा था, आयोनिक बॉन्डिंग में पढ़ा था कि ionic compounds can conduct electricity in molten and aqueous form because they have free ions over there. That means they have free moving ions in molten and aqueous states. Fine. If you have NaCl, there is a lot of attraction between the particles. If you heat them, if you melt them, then the electrostatic force of attraction between the ions are going to be overcome by the heating at 800 degrees centigrade, and then ions are going to be far apart from each other. They are free moving ions. That's fine. But what happened with water? Water ऐसा क्या कर रहा है भाई? पानी के अंदर आपने NaCl को डाला, and the ions are going to be dissociating into far apart from each other, right? Like this, and they are just dissociating into the solution, and they are going to conduct electricity. Heating के बगैर हो गया. ऐसा क्यों हो गया? This is what enthalpy change of solution. This is what enthalpy change of solution. This is all we are going to see in this topic. Just look at over here the diagram. This is the diagram. You can see this diagram that if we have NaCl, this is, for example, NaCl or any ionic compound, right? So we know that in any ionic compound we have actually positive and negative ions over there. So you can say that NaCl are like this. Ionic compound, this is a combination of cation and anion. When you dissolve them in water, they will form cation aqueous, anions aqueous. And if you are getting an example of NaCl, so when you dissolve NaCl in water, it will form NaCl or Na aqueous or Cl aqueous, right? Chloride ions and sodium ions in aqueous state. So how they are going to be formed, just look at over here and in this example. So if you talk about any ionic compound, when you dissolve them into the water, when you add them into the water, if they are going to be solubilized, so what are going to be happen with them or with these molecules? What are going to be happen with them, right? So you just look at over here. This is a negative particle of the ionic compound. So this negative particle are going to bond with the positive of water, right? Same as it is, the positive particles of the ionic bond are going to bond with negative particle of the water, right? Just look at over here, the same thing in ionic bonding and the same thing over here as well. Just look at over here, a single positive over here is going to bond with 6 water molecules. These are 4 molecules and definitely one is top and one is bottom, और you can say that एक आगे और एक पीछे भी होगा, ठीक है ना? 6 bonds बनाएगा water molecules के साथ. And if you remember the energetics of your O levels or your AS, so you need to understand this, that the bond formation is actually the exothermic reaction. The bond formation is actually the exothermic reaction. We know this. बॉन्ड फॉर्मेशन क्या होती है? एक्सोथर्मिक. तो जब 6 नए बॉन्ड बन रहे होंगे तो डेफिनेटली वो कुछ ना कुछ एनर्जी रिलीज कर रहे होंगे, और वो जो एनर्जी रिलीज कर रहे होंगे उस एनर्जी की वजह से NaCl is going to be dissolved in that, or it is going to be dissociate in the water or in the aqueous solution. This is the thing, and this is known as what? Energy of hydration. This is known as the energy of hydration. Just look at over here, a single positive of any ionic compound is going to bond with 6 water molecules, and same for negative as well. A single negative is going to form 6 bonds with water molecules. So a single NaCl is going to bond with 12 water molecules, and definitely after the formation of such bonds, they are going to release the energy, and such energy known as energy of hydration, which is going to dissociate the ionic compound into the water. And what is the type of bonding over there with these water molecules and NaCl compound? This is a dipole-dipole attraction, right? This is intense dipole attraction, right? So this is actually, you need to understand that when any ionic compound or when any ionic crystal or when any ionic lattice is going to dissolve in water, the water molecules are starting making bonds, and these bonds are actually intense dipole-dipole attraction, right? And we know that every negative of ionic compound is going to bond with 6 water molecules, or the positive of 6 water molecules, and every positive is going to bond 6 negative of water molecules, right? And they are going to produce energy, and this energy is known as energy of hydration. This is actually energy of hydration, which is going to overcome the bond energy or the electrostatic force of attraction between the ionic compounds. Is that clear, Richo?
Sir, when cations and anions dissolve surrounded by water molecule, तो जो वो energy release करते हैं उसको energy of hydration कहते हैं.
जी, उनके बॉन्ड जो बन रहे हैं ना, जो 6 बॉन्ड बन रहे हैं पानी के साथ, एक पॉजिटिव का 6 बॉन्ड बन रहा है, तो बॉन्ड जो बन रहा है ना, वो है एनर्जी ऑफ हाइड्रोजन. उसकी वजह से जो बॉन्ड बनने की वजह से जो एनर्जी रिलीज हो रही है ना, दैट इज एनर्जी ऑफ हाइड्रेशन, राइट?
Yes, sir.
Now, this is the thing that you need to understand, right? And if you remember that in the previous chapter, we were talking about that Na positive and Cl negative ion must be separated from NaCl right now. In the previous, if you talk about like a Born-Haber cycle, so you know that we were talking about that if Na gaseous or chloride gaseous is going to combine together, they are forming NaCl solid. This is what lattice enthalpy. This was what lattice enthalpy, right? But right now, this is something different, right? This is what this is NaCl is going to, which is solid, is going to dissociate into Na ion, which is aqueous, and chloride ion, which is aqueous. So this is something different, right? This is what this is enthalpy change of solution. This is what this is enthalpy change of solution. This is enthalpy change of solution, right, bacho?
Yes, sir.
Now we are going to discuss this later on. Let's move on a little bit. Just look at over here. Enthalpy change of hydration. What is this? Enthalpy change of hydration. Enthalpy change of hydration is something like if you have any calcium or any ion and sodium and chloride and an oxygen ion, when they are in gaseous state, when they convert into aqueous state, this is what enthalpy change of hydration. This is what enthalpy change of hydration. So remember this: if any ion in the gaseous state is going to convert into aqueous state, right? This is what enthalpy change of hydration. This is enthalpy change of hydration of calcium, right? If you have multiple ions over there, then that means you are having multiple hydration. For example, if you have calcium chloride, so you must have calcium ions over there, right? They are going to convert into calcium ion aqueous. So this is the enthalpy change of hydration of calcium ions, right? And you must have chloride ions over there as well, which are gaseous in the start, and you are going to convert them into aqueous as well. So this is the enthalpy change of hydration of chloride ion. And if you want to calculate them, so you need to multiply with 2 as well. Because you know that in each molecule we have, in each compound we have 2 chloride ions over there. Is that right?
Yes, sir. Sir, when the ionic compound changes into aqueous ions, it is in solution, enthalpy change of solution.
Yes, it is solution. When ionic compound is going to dissolve in water, this is the enthalpy change of solution. When gaseous ions are going to convert in aqueous solution, this is hydration. And when gaseous ions are going to convert into solid or ionic solid, it will be the lattice energy, which you learned earlier, right? So this is the same thing over here. You can see this, that this is sodium chloride solid, right? We learned this कि gaseous ion से अगर sodium chloride बनेगा, तो this is actually what enthalpy change of lattice, right? We learned this, right? And in today's class, we learned this, that if this solid NaCl solid is going to decompose or going to transfer into aqueous ions, so this is what this is actually enthalpy change of solution. This is actually what enthalpy change of solution. This is the new thing that we learned today. And the new thing is, if sodium gaseous ion is converted into aqueous, or if chloride ion gaseous is converted into aqueous, so this conversion is known as enthalpy change of hydration of each specific ion, right? Now, if you focus over here, or if you want to solve in this way, so you can solve in any way, right? For example, if you focus like this, which arrow is going to be same? So just look at over here. This arrow are in the same direction, right? This arrow going to connect with the upper one, and it is going to be like this. Yeah, lattice enthalpy of NaCl plus enthalpy change of solution, and it is actually equal to the enthalpy change of hydration of sodium plus chloride, right? And if you want to find out the enthalpy change of solution, so you can simply send enthalpy change of lattice enthalpy over there. So it will be the enthalpy change of hydration of each salt, or sorry, each ion, right? Minus enthalpy change of lattice energy. So you can even solve like this, or you can even do in this way as well. If you want to do that, it is actually the reverse, If you want to use the reverse one, so you can use the reverse one as well. Otherwise, you can simply say that कि ये minus है तो इसलिए reverse है. Or if you want to put positive over here, so ऊपर वाला हो गया. मर्जी आपकी, जैसे आप use करना चाहें. Right बच्चों?
सर ये रिवर्स वाली बात समझ नहीं आई.
रिवर्स वाली बात आपके समझ में नहीं आई, कोई मसला नहीं. वहां जाके नेगेटिव हो गया तो आप नेगेटिव के साथ लैटिस एंथैल्पी लिखा हुआ है तो इसका मतलब ये रिवर्स लैटिस एंथैल्पी है. और अगर आपको ऐसे समझ में नहीं आ रहा तो आपको ये बात पता है कि आपके पास NaCl सॉलिड बनता है किससे? सोडियम आयन गैसियस प्लस क्लोराइड आयन गैसियस से. ऐसी बनता है. तो दिस इज व्हाट? एंथैल्पी चेंज ऑफ लैटिस एनर्जी, राइट?
यस सर.
और अगर सॉलिड से वापस गैसियस आयन्स बन जाए तो ये क्या हो जाएगा? रिवर्स. This will be the reverse of enthalpy change of lattice energy, right?
ओके सर.
This is actually what you need to understand in this, and that's pretty simple. If you want to solve some questions about this, it is very, very simple, right? You just need to understand this, that we have any solid which can be converted into gaseous ions, or gaseous ion can even converted into solid. So if it is converted into ions, so this will be the lattice enthalpy, which is actually reverse, right? And these ions, we know that can be converted into aqueous ions, and we know that this is actually what? This is what? This is the hydration enthalpies, right? And we know that if solid sodium or chloride or any ionic compound is going to dissolve in water, it is going to form aqueous ions. So this is enthalpy of solution. So this is what you need to form in the vertical form, right? This is the vertical form of this. This is pretty simple, right? So all the things in the questions are actually given to you. They gave us the lattice enthalpy of NaCl. जब ये बनेगा तो इतनी energy release होगी. They give us the hydration of sodium ions. जब sodium ion hydration होंगे तो वो ये हाल होगा उनका, ये energy release करेंगे. और अगर chloride ion hydration show करेंगे तो they will show this energy change. So this is nothing. We just need to put them in the formula and get the answer. We know that reverse of lattice enthalpy plus hydration of sodium plus chloride will give you the enthalpy change of solution. So we know that what is lattice enthalpy over here? It is minus 776, and it is reversed, so we use the negative sign over here, and the sum of the hydration energies of sodium and chloride, and it will give us 5 kilojoules per mole. It means कि आपके पास जो पानी में NaCl आप डिसॉल्व कर रहे हो, it is a slightly endothermic reaction. It is a slight endothermic reaction. ये थोड़ा सा endothermic है. इवन के आप एनर्जी दे नहीं रहे हो, 800 डिग्री सेंटीग्रेड पे NaCl डिसॉल्व और डिसोसिएट होते हैं इसके आयंस, और जो है वो मेल्ट होता है 800 डिग्री सेंटीग्रेड पे. अभी आपने सिर्फ पानी में डाला है तो उल्टा आपको 5 किलोजूल्स की एनर्जी एक्स्ट्रा मिल गई है. अ लिटिल बिट एंडोथर्मिक रिएक्शन दिस इज, जब आप पानी में नमक डिसॉल्व करते हो. इज दैट क्लियर बच्चों?
यस सर.
चलें, so let's solve this question. This is your task now.